Devin Petersohn, co-founder and CTO of Ponder, and most importantly for the podcast, the creator of Modin. And we will get into what Modin is during this conversation. Welcome to the Data Exchange podcast, Devin.
Thank you, Ben.
And I've known Devin for many years. I forget exactly when, but we either met each other on the beach or in the slopes and during winter in one of these retreats that Rice Lab would put on, where Devin was a graduate student. So Modin, I went to the website and I always grab the tagline when I talk to open source project leaders. So your tagline is speed up your Pandas workflows by changing a single line of code. So does that adequately describe Modin?
In one sentence, yeah, that's probably the easiest way to describe it. Yeah.
And so what led you to Modin? So why does Modin exist?
Yeah, so it's interesting. So I started my PhD in working in genomics and working with domain scientists. So I got a good feeling for how scientists think, and I built large-scale software on Spark, big data stores for these genomic workloads. And what I noticed is that we had a hard time getting scientists to adopt our big data tools because they were just so different and so cumbersome compared to what they were used to. And so the Modin work around creating a drop-in replacement for Pandas and just making it easy for data scientists to scale up their work from what they're currently doing, that came from the learnings that I had in the kind of scientific side of things, where data scientists in a similar way, they don't like learning new things. So it's a different mindset than a typical engineer. They prioritize their own productivity, and rightfully so, because they're under a lot of pressure in a lot of cases. And so by prioritizing their own productivity, a lot of times they don't have time to really learn these new tools and learn distributed computing in order to scale things up, because all of these tools that allow you to scale, they had all these extra requirements around, scalability, learning about how to parallelize your code, and working with some weird parallelization issues. And so the whole motivation of Modin came from this idea of me talking to one of my data scientist friends who was like, Pandas is an issue for me. And I was like, okay, let's see if we can kind of scale this up. And I wrote a blog post about it, and it got more attention than I thought it would. So from there, it just kind of grew very quickly.
So let me ask you this, Devin, when you say they had a hard time with existing big data tools, so this is so even when you set up the cluster for them, and so they don't have to do any DevOps or any kind of sysadmin kind of thing. It's just that the API is sufficiently different, and the programming style is sufficiently different that it just got in the way of their work.
Yeah, I mean that's the way that I like to put it is that the Pandas really gives you this feel for controlling your data, and these big data tools have always felt like you're kind of just kindly asking the cluster to do some work for you, or please will you at some point in the future execute my query. And it didn't give you that feel of okay, I'm really grasping my data, I'm really kind of controlling it and manipulating it in exactly the way that I want to, which is a hard thing to really mimic, but it's something that we spent a lot of time on with Modin, is this kind of interactive mode. So even setting up that cluster though in the first place, and a lot of data scientists, it's not just the API, it's also the programming model. It's things like lazy evaluation, which kind of force you to think about the way you're programming in a different way. You have to start thinking about materialization and if you're going to leave for a meeting, should you just go ahead and force the query to execute or not? Those sorts of things kind of that there are things that data scientists aren't used to having to think about and deal with.
So Modin in the beginning, what were the must-have features, and what was the initial goal? What was the MVP of Modin?
Yeah. So the first goal was to basically parallelize pandas, make pandas work. And early on we focused on the single node, the single machine use case because that's where pandas users were. And so
So just to clarify, Devin, so Pandas right now, if I have a laptop or a server with many CPU cores, it cannot take advantage of that, right?
that's right. Yes. So even if you get the biggest instance possible, pandas will still be running single threaded. And it's limited to what can fit in memory pretty much. And so the MVP of Modin was to basically distribute as much of pandas as possible and basically create that a scalable single node implementation first, and then move on to the cluster after that. And so that's kind of where the MVP was.
And then what did that mean? So for people who are not into the innards and details of pandas, did that mean not using pandas at all and building a system from scratch? Or could you take some existing parts of pandas and fork it?
Yeah, so Modin is not a fork of pandas. This is a great question. I think it comes up. It's been coming up more, I think, lately. But Modin is not a fork of pandas. Modin does reuse some components and some pieces of pandas, and I can talk at various lengths about the innards of Modin. But basically, what we did is we kind of started from first principles and said, how would we design this if we had this API? How would we design this from an algebraic perspective? How would we design a math that we could use to describe these operators? And then we went and we built the kind of physical layer or the partitioning, and we looked at how do we decompose this algebra into and make it parallel. And there are a lot of tricky things about parallelizing certain operations and certain combinations of operations that require different levels of parallelism. And so this is something that's kind of unique among Modin. If you compare it to other distributed systems that kind of focus more on row parallel or data parallel operations, we really took this approach that if we're gonna do pandas, we're gonna do it right. We're gonna keep the API just so that we make the data scientist as productive as possible. But then we basically started from first principles and ripped out the whole backend. And so in the current implementation, we do use some of pandas, some things from pandas. We parallelize pandas, but those pieces are pluggable as well. So we in the future, we may not need to depend on pandas at all for any of these components.
So going back to this notion of the MVP, and I've talked with you about this in the past, and I may have even seen you give a talk about this in a Rice Lab retreat. But Pandas is a big API, right? As many people know, and in fact, I personally, when I use Pandas, I probably Google 90% of what I need because I never remember how to do things, right? When you looked at that in the beginning, was it daunting? So how did you approach this Pandas API? What's the goal? You can do everything that you're doing in Pandas.
Yeah, that's still the goal. And we have this kind of since we have this math that we can use to describe the API. Part of my thesis, actually, my PhD thesis was around the kind of proof by exhaustion that we can express everything in this algebra. And so really it's possible, provided you don't do some of the weird pandas things like looping over rows individually, right? That's something that we don't currently parallelize, and maybe in the future there's a way to kind of batch these things and parallelize them. But if you're individually modifying each row or pulling out individual values from each row, that's not going to be parallel because the for loop itself is something that's outside of control.
From a developer or data scientist perspective, that just means that your code will still run, but it may not take advantage of Modin's strength.
Exactly. Yeah. Yeah. And with there are people who have raised issues on the GitHub before, and we've shown some benchmarks. Basically, it's either about the same, maybe slightly slower in Modin if you're looping over things, just because the row might be on another machine, and so there's a little bit of overhead for pulling that row if you're going to modify things. But yeah. Yeah.
So if you're fairly reasonable data scientist doing only reasonable things, Modin will parallelize most of almost everything you do at this point.
Yeah, it's about 90%. And I wouldn't say like only a reasonable person doing only reasonable things. I mean, like there is a lot of like really messy pandas code out there, and I've seen a lot of that. And like I don't want people to be punished for writing that kind of code, because pandas is used in such a prototype way, right? It's like I want to go and build something really quickly, and I'm not thinking about how I'm structuring my code. That's the way pandas is often used. And we, in the same way that SQL doesn't punish you for writing things in the wrong order, Modin, what we're working on right now with like query optimization underneath the hood, is that Modin will not punish you for writing this type of quick iteration prototype type of code. It's really intended to allow you to just like get the best performance just out of the box. So
to people who are listening to this, who might say, well, I'm only mostly working on a laptop, so I don't need Modin. You say what?
So Modin will still work on a laptop. It'll still distribute the code on your laptop. And so if you're operating on, like 100 rows, you don't need Modin. Definitely not. But if you're operating on hundreds of thousands, tens of thousands, hundreds of thousands of rows, and you have some computationally intensive things that are taking multiple seconds, that's where Modin starts to come into play and make things feel a bit more interactive and look a bit more interactive. And so if you're pressing run and then waiting a few seconds, that's a good time to bring Modin in, I think.
So the other question is, I have code where I'm using pandas to do a few things, and then I pass it on to another library, say a machine learning library, and that library is expecting pandas. So if I bring in Modin, will my pipeline still work?
Yes. So the code, the consuming library, even if it's expecting pandas, as long as it's not doing like an explicit type check for a pandas.data frame, everything will work just fine. And most of these libraries don't actually. Scikit-learn, for example, Scikit-learn will either convert it to a NumPy, or it will just use the APIs, check that the APIs exist first, and then use those APIs. So Scikit-learn is operating at the API level. And so some of the things that you do in Scikit-learn will even just be able to leverage Modin and Modin's, distributed computing just straight out of the box. If it is converting it to a NumPy array, we go ahead and convert it to a NumPy array in the same way that you would expect. And then the machine learning library kind of takes it from there. So yeah, outside of this, like very, very specific checking for the exact type, everything works. And Seaborn, is one of those libraries that in the past has checked for that type. And so there are some issues with Seaborn specifically, but I haven't heard of any issues with any other libraries.
And so have you tried to profile Modin users and the way they use Modin? So anything you want to share with us there? So what are some common usage patterns for Modin?
Yeah, I'm happy to share. So we don't, so just as a caveat, we don't track users or like profile them in this way. These are just people who've come to us and who've told us.
So you don't have any kind of metric gathering.
Exactly. Yeah, we don't track. We don't do any telemetry or check anything on users. I really don't want to do that. Honestly, I want people to just like be able to enjoy the library without having to feel like they're giving me their information or anything like that. So what we do is we talk to a lot of users though. And so we have a number of use cases, and like the community's been growing really, really quickly. And I feel very lucky to be in this position, but we have use cases. I can share a few, I guess a few specific use cases or case studies, if that helps.
Yeah. So what are some of the let's say you're giving a keynote about Modin, and I give you 5 slides for examples of how Modin is crushing it in a specific company or use case. So what would those 5 slides be?
Yeah. So I can't share any company names yet, but I can share like general things about these use cases. So we worked with an online retail company, one of the biggest, and they were running into bottlenecks with Pandas. Basically, they had a workflow that would run.
Wait. Stop there. They're one of the
Yeah.
biggest retail companies. They're doing.
No. Sorry. One of the biggest online retailers, one of the big ones.
Yeah.
Yes.
Anyway, they're big. They're doing data
Yeah.
processing, and they're doing it in Pandas. Come on, man. They must be doing something else like Spark or something.
So it may surprise you, but every company that we talk to, every company that we have met has the same problems with Pandas and still runs things in production in Pandas, or they prototype things in Pandas and move to production. So this is a common theme, and Modin is like kind of here to help, if you will. So
and why is that? Why is that? Is it because a lot of that initial work is in the data science team?
Exactly. So there's a difference between what the data scientist knows and the data engineer knows in a typical company. And the engineer is more knowledgeable about how to productionize things and the kind of production environment.
They have different tools, and they also have different tools.
100%. Yes. The data scientist is more familiar with the domain. They're more familiar with how, the kind of data should look, what to look out for in the data, and of course statistics, and they know basically generally how to run and build machine learning models. And so you have this disconnect where the data scientists don't know how to write these distributed computing pipelines and these big distributed computing programs, and the data engineers don't know the data well enough and don't know how to build the models well enough to actually help in that front. So all of this is kind of stemmed from the fact that like Pandas can't scale, and a lot of the tools that data scientists use don't scale. And so if they were able to scale, then a lot of the things that data engineers spend their time doing, a lot of boilerplate stuff that isn't fun, like translating Pandas to Spark or translating Pandas to Hive, or whatever you're using, right? Some kind of SQL system. A lot of this translation work is like very boring, and I think like it stems from this need to have a system that can do both small and large scale and kind of bridge that gap. And so yeah, even the big companies have these same problems with using Pandas and running into bottlenecks with Pandas. Money isn't the problem here, right? Like scale isn't the problem, and scale of your team isn't necessarily the problem. It's really the tools and like the kind of human time that it takes.
You use 2 P words in the same sentence: Pandas and production.
Yeah.
So people are pushing Pandas to production.
Yes, 100%. Yes, there are. You'd be surprised how much Pandas runs in production, and yeah. And so this company that we were working with, they had a pipeline that was slow, and they had to basically manually chunk it up and run it in stages because they were running out of memory and they were running out of the compute time. So they were doing all this by hand. And this is a theme, by the way, the kind of handcrafted working around Pandas. It's a whole theme that you'll hear among a lot of these use cases. But they dropped Modin in. We got rid of the kind of the manual handling of the data, so the code got simpler, and they were able to do 1000x the data just like straight out of the box, no extra effort outside of like removing code, which every engineer loves to do, right? Deleting code is always better than adding code.
By the way, one thing that's happened in the last few years that's interesting is that there's at least some kind of coalescing around language between data engineers and data scientists. So data engineers are increasingly using Python and SQL, but in the past, right, so they would still use Scala or Java and things like that. But now many of the data engineering tools of this generation of the so-called modern data stack, it's either Python or SQL. So maybe there is an opportunity here to really kind of blend these two teams more closely together if they can just kind of have a common tool set, right?
Yeah, definitely. 100% agree. Yeah.
Yeah. And so then, so you've got this e-commerce or retail thing. So what, any other examples?
Yeah. There's a, like, it's not just in like these kind of e-commerce or like maybe a more traditional, like, consumer business, but there's actually like B2B companies that sell AI tools that we've found a lot of interest in using Modin. And we worked with one of these companies who they were actually trying to use Dask to parallelize things. And they found that Dask is a little bit quirky, and it requires you to kind of
A different API.
hand do things. It's a different API.
Yeah.
And these engineers, by the way, are world class, right? They're like the types of they like build AI tools, right? And so the different API wasn't so much the issue. It was more that like there were all these weird quirks and these like corner cases that they were running into based on their workload that really caused the differences between Dask and Pandas to become like more and more exacerbated and kind of just creating problems for them. And so we worked with them and we were able to get them, to delete about half of the code that they had in these certain functionalities that relied on Dask, and which is like a huge amount of code, right? That just kind of shows how much like hand tuning they were doing to try to squeeze performance out of Dask. And we were able to match the performance that they were getting before, but and also delete all of this code. And so really, like, it's this theme of these folks wanted to be able to prototype quickly and add new features quickly, and they wanted to be able to get them pushed to their customers fast. And so these are running in production as well. They're like entire applications that are built using Pandas. And so the whole idea here is that moving from this prototype to production is very costly, right? And you don't want to have to write two different workflows to kind of do the same thing based on the just based on where it's running, right?
So I know that Modin uses different execution engines, right? So it can use Dask or Ray. And by the way, there's even a project called Dask on Ray, which actually has found success in rather big companies like Amazon, where they take the Dask API and run it on Ray. But anyway, but you've consciously made a choice around Pandas, right? So Pandas is the API that people are using, and we're going to bet on Pandas. So what's your sense? Is this going to, so Pandas is here to stay?
Yeah, Pandas is here to stay. I don't think anybody would ever disagree that Pandas is here to stay. Yeah. Its usage is on par with the number of people who use Python. Like there are so many people who use Pandas. It's on the order of tens of millions, at least, but daily users, which is about how many daily users Python has.
Yeah. So for me, I don't mind it, but like I said, I can't remember most of the things that I need to do.
Yeah.
It's not as easy to remember a SQL, for example, right? So learning with SQL, the syntax is so simple in SQL, right? I guess the most complicated thing you can ever have in SQL is maybe an outer join, right? So, other than that, it's quite simple. So why is it that I guess it's also lack of tools, right? So for data scientists to use SQL, they will need tools, and Pandas just comes with Python, just comes with it.
That's right.
But if you imagine a world where there's a SQL tool that data scientists could use, wouldn't they use more of that for at least the things that where SQL makes sense?
Yeah, so potentially, definitely. I probably have some maybe controversial opinions in this space, but
we love controversy, man.
So I don't think that by and large that data scientists will move to SQL or that they'll move away from pandas anytime soon. And I think that like
Okay, so you have to give us a reason why. Yeah.
Well, it just goes back to like my observations that data scientists basically prioritize their own productivity. And if they can be more productive in a certain language, then that's the language that they'll choose.
And
Now,
by the way,
I will caveat.
I just want to interject that SQL is cool and great once you get it, but surprisingly, there are some really great developers that can never think in terms of set theory and SQL.
Yeah.
So I think it's not as natural as we think for people to think.
Yeah, I mean, it really does require you to kind of think about things differently. You like with pandas, you can kind of like prototype and test on the fly, whereas with SQL, since it's like it's a declarative language, so it's everything up front. You have to give the whole query before you execute anything. In that case, then you kind of have to build these SQL statements incrementally and then like wrap that. And it's much more complex to kind of prototype or debug or be an interactive SQL user than it is to be an interactive pandas user, because pandas is imperative. It's
and
like
this is the key word here, interactivity, right? So
that's exactly right. Yeah. And so a lot of my work in the PhD and a lot of the work around Modin is in optimizing for this interactive use case, because I really do think that it's something that's been kind of like put aside or ignored for a long time in terms of like how people build these kind of data pipelines, and the interactive piece of that is so important. It's where people spend the most of their time, and yet it's been completely neglected. And you can't optimize for things in the same way that you do batch. It's totally different. You have to think about you have to kind of think about when is the user, when there's user downtime, can we kind of pre-compute some things, or can we have some summary statistics that we compute behind the scenes. Whereas when you're in a database, the database can kind of the database is sitting there, it's already optimized. It was optimized as it was being put in, and there's a DB admin who kind of like tweaks things to make things run better and faster. And so all of that is kind of abstracted away in the SQL sense. But in the pandas case, in the interactive case, we're doing a lot of the kind of novel work in optimizing for that interactive use case.
Yeah, and it's a kind of a very subtle thing, because in like you described, in the data science world, you're doing some exploratory data analysis. You're kind of studying the data, then you're slowly building a model, right? So there's a lot of interaction going on. In the data engineering case, you kind of know. In many cases, you kind of know the task. I need to move this data from here to here, merge it with this data. So you're building this pipeline in a serious way, almost from the beginning, right?
That's right.
There's a lot more specification in the data science world. You don't even know what data you need until you start playing with it. And is it helpful to my model, or is it not? Is it just adding noise? And so it's a very different kind of paradigm in some ways. So what was the founding date of Modin?
What was the what? I'm sorry.
What was the date Modin started? What year?
Oh no, I'm gonna embarrass myself here because I don't. 2018, I believe. 2018.
So 2018. So it should be done by now, right? So we're done.
I think no project is ever done. But
so where is Modin today in terms of single node and cluster, and what's on the near-term roadmap?
Yeah, great. So in terms of single node and cluster, both are fully built out. In terms of the Pandas API, we're at about 91 or 92% of the full Pandas API. We're planning on wrapping up the rest of that kind of tail end of the 8%, later this year, maybe early next year. And then, we're really focused on, like I said, the kind of query optimization and optimizing for that new workload, which is the interactive use case. and continuing to build out a lot of the stuff that we've done on the research side and that we've kind of prototyped. But in order to make it production, like research and production is like there's orders of magnitude difference in how long each of them takes. So you know, building that out and actually making it robust and kind of testing it with our, you know, our very friendly and wonderful community. You know, that's kind of what's on the near-term roadmap.
And so in terms of let's see, the cluster implementation of Modin, are there people already using it in production?
Yeah, so definitely the AI use case that I mentioned earlier, they're using Modin on a Ray cluster. They were using Dask on Ray, and they kind of switched to Modin because of the quirkiness of Dask, like I mentioned. But there's also you know, a number of other companies, a large telecom company, for example, and you know, a large financial institution. They're using Modin in a distributed environment, definitely multi-node.
So now you and your colleagues in Berkeley started a company called Ponder. So I'm pondering the mission of Ponder. So what is the mission of Ponder?
Yeah, so our goal is basically to bring a product that focuses on data scientists' productivity and helps them move their workflows to production. So that whole motion that I mentioned about going from prototype to production, that's a common theme and a common pain point among every institution that does data science. Like it's just universal. It's kind of scary how problematic it is, because all of these companies that we're talking to have this issue of moving from, you know, single workflow notebook prototype to production. It just takes a lot of human time, months, many months in some cases, to go from one time in, if ever, because some of these use cases, you know.
So then that means that Modin is going to be central.
Modin is central, yes, to what we're building, and that's actually, like, the open source is a very heavy focus of the company right now, but continuing to build the open source and grow the open source and make people successfully using the open source.
So a question that listeners might ask is if that's your mission, isn't there a bunch of data science platforms already? So that are, I guess some data science platforms may not actually, they're just data science platforms and they're still decoupled from production. So, but what is the difference between what Ponder is trying to do and these data science platforms?
Yeah, Modin is the real differentiator here in terms of allowing the same API to operate at different scales. And so we, a lot of times, you know, we have current customers who are basically operating on a single node and moving to production, and they're kind of two different data stores that Modin is directly pushing computation to. So this kind of pandas on everything, like translating Modin into like a pandas on everything, being able to execute Modin on top of your database, on top of your data warehouse, on top of like whatever you have set up.
Oh,
right?
really? So really, I can point data. I can point Modin ultimately to like Snowflake or Databricks, or
eventually, yes.
Name your database kind of thing.
Yes. So not all of that is, some of that is prototyped and it's not fully like we're working.
So you will need a family of these connectors or integrations.
Yes. And we've already built the kind of prototype for these things, and we're working with our current customers and design partners to kind of you know, to flesh this out and make sure that it's good.
Which means what ultimately. So for example, I point Modin to a data warehouse. This data warehouse has a star schema. So then now I'm going to start doing some joins or do I do the SQL statement in the data warehouse first and then create a data frame in the data warehouse, then pull it into Modin? So what's the workflow?
Yeah. So Modin can actually push computation to the data warehouse, let's say. So if you'll just be writing pandas as you would, and if the data warehouse if we can express that in SQL or whatever, that the data warehouse speaks. We will push the computation directly to the data warehouse. The data will stay in the data warehouse. We won't pull it out. I mean, like once you start pulling data out of the data warehouse or the database, scalability issues start coming really into play, because it just takes a long time to move data over the wire, and to like translate that data into some format that Modin recognizes. And so all of that is kind of challenging. So what we've been building upon is a way to run Modin on everything, push computation to the data stores. It's going to be faster there than it will be in Modin, because they've optimized these queries against their own format. So pulling the data out, we immediately lose all performance. So that's basically what we're building. We're getting a lot of excitement around this.
So it's like the data warehouse becomes another execution engine, kind of like another array or another Dask.
Exactly.
But then, if you're a data scientist, your user experience is still Pandas.
That's exactly right. Yes. Yes. Nothing changes from your day-to-day, basically, but it's just executing somewhere else. And data scientists don't actually care where it's executing, from my experience. So whether it's executing locally or remotely, we give them the same experience.
Right. And so then, how many of these integrations do exist now?
So like I said, nothing is open source yet. All of these are things that we're working with design partners and current customers on. We're happy to kind of we've done this for a couple of databases. I'm not really comfortable saying which ones.
By the way, so what's the separation between Modin open source and Ponder? What are some of the key separations there?
Yeah, so Modin will always be open source, and we'll always have the ability to run Modin on a cluster. We plan to open source a lot of these data connectors directly to databases like Postgres and that sort of thing. But the whole idea around kind of doing this for the user and like having that experience, improving that user experience, that's what Ponder's about, is kind of on top of this kind of Pandas on everything, building the experience, building out the kind of capabilities of improving data scientist productivity. My co-founder and CEO Doris created a project called Lux, which is it kind of gives you almost BI-like capabilities within the notebook, and so that's also open source. And so basically what it does is it generates a bunch of visualizations for you based on what's interesting within the data. And many years of research went into kind of building that visualization recommendation system, but that's not something that you can get anywhere else in the notebook these days, because the kind of recommendation system itself, that's something we're constantly hearing positive feedback about, improving productivity and letting this interactive use case, right? The kind of quick iteration, that's really what we're focused on. So,
by the way, a validation for this whole space is just the amount of projects in activity, right? So we mentioned Dask. There's Dask on Ray. There's Modin, obviously, and then there's this thing called Mars that I don't actually understand what it is. And then there's another startup. Is it called Boda? Bodo.ai.
Bodo.
Yeah. That's kind of coming from the HPC world, right?
That's right.
And so so that just means that there's a lot of demand for getting data scientists productive, in the sense that can they do their work at scale using familiar tools, right? So this is extra validation. So in closing, Devin, for listeners that have not yet used Modin, right? So you obviously encounter a lot of people probably who are Pandas users who are hesitant to use Modin for probably the same reason that I kind of described earlier, which is basically I have code that assumes Pandas, right? So I'm not just going to work on Pandas, but I'm going to pass Pandas to something else more important. So what are the other hesitations that people have, and maybe you can try to talk them out of it in the last few minutes?
Yeah, I mean, hesitations people have generally are around like thinking about Modin as a fork of Pandas or something like that, and thinking that it's going to somehow change the way that things do, or the things happen. So I can kind of hopefully put people's minds at ease. We throw the exact same errors as Pandas. We have the exact same arguments as Pandas. The API is 100% a drop-in replacement for Pandas. When you hand things off, we've done a lot of work on the internals of Modin to basically make it so that the library that's consuming Modin treats it as Pandas, and there are lots of things within Python built-ins to let us do that as well. So another thing that might put someone's mind at ease would be that we've done a lot of work to make it easy to switch back from Modin. So it's a drop-in replacement, meaning that you change the import statement, but you can also just change it right back. So it really is a very lightweight way of testing things out.
And your code is as is, right?
Exactly. So
so if you have, in other words, if you have an import Pandas as PD, you can just replace that, keep the PD, and maybe just don't even change any of your code, right?
That's exactly right. Yeah. So there's no it's as lightweight as possible in order to try it out and to give it a shot. And that's been the motivation from the beginning, is the ability to go to and from.
And the claim is, and I think it's verifiable claim, is that you will notice immediate benefits even on your laptop.
Even on your laptop, yes. We have published academic papers, peer-reviewed papers, where we publish benchmarks run on a laptop because that was explicitly asked for by the committee. So yeah, yes, it's verifiable even in literature.
Actually, I forgot to ask you this, but in closing, so is there an ecosystem now around Modin? In other words, here's Modin at the bottom, and then here's these tools that are starting to use Modin, BI tools, ML tools. And so what is the Modin ecosystem now?
Yeah, so I encourage everyone to join the Slack. Modin.org/Slack is how you can join. We are building out this ecosystem as we speak, with like a spreadsheet application that can communicate to Modin using our underlying algebra, and SQL APIs. Lux is something that we're doing on the, that we're integrating on the Ponder side. And so, a lot of the ecosystem around, consuming Modin, and also like taking Modin objects and distributing them. Modin is compatible with Ray machine learning libraries, and it's compatible with XGBoost. We have an optimized version of XGBoost that we kind of implemented and plan to upstream. So the broader ecosystem is growing constantly, and there are probably some that I even forgot here, but yeah, I mean, we're seeing the growth before our eyes.
Yeah. And with that, thank you, Devin.
Thanks, Ben. Always a pleasure.